Okay, before we start, can you guys just confirm that you guys can hear me and see my screen and see me as well? Okay, perfect. Just going to give 1 or so minute for the YouTube people to join. And we can begin. Okay, should be good. Okay, assalamu alaikum and good morning. Welcome back, guys, to grade 10 maths, okay, by Inspired Teens. Hope that you guys had a good week of school. Today we're going to be doing, continuing algebraic expressions, right? Just quickly before we get started, just let me know once more, what are you guys currently busy with at school? In the chat, just let me know. Okay, and then again, just a reminder, if you guys do have any questions, please feel free to ask it in the chat, the Q&A or the YouTube chat. And please remember that the document that we do, all the notes that basically that you see on your screen, will be sent to you afterwards. And every week the Google Drive is updated. Okay, so some of you have started with trig, some are doing exponents. Okay, hopefully we'll get to exponents in this lesson. And then eventually trig. Those are exponents. Okay, cool. So we sort of getting there. Okay, so when we ended last time, I believe we ended on a trinomial example. Okay, so let's just do maybe 2 more and then continue. All right, we can just revise how to do it. Okay, algebraic fractions. Okay, cool. Okay, so this example is one of 2. You can group it or you can factorize it. All right, let's maybe do let's do this example and maybe we can go back to the example and you guys can. Okay, let's leave out this. Let's do this one and then we'll do number 2 and I'll show you the 2 ways to do it, right? So let's look at number 2. I hope you guys have been practicing trinomial factorization either way. So firstly, remember we discussed, even I forgot for the first question last week, I think maybe 1 or 2 questions, the HCF, right? Whenever we are factorizing, we are busy with factorizing, we completed simplifications, right? We discussed simplifications, monomial by polynomial, binomial by binomial, squaring a binomial, difference of 2 squares, binomial by trinomial, and some mixed questions, right? Then we did some factorization where the first thing we look at is the highest common factor. So if we remind ourselves of our steps, we have looked for common factor first. If a binomial, if it's binomial, look for dots or difference or sum of 2 cubes. If it's in the trinomial form, then factorize, okay, to a quadratic equation factorization or trinomial factorization. If there are 4 or more terms, you can try to group, okay. Don't forget to factorize as far as possible. And remember, terms in brackets can be considered as a variable, right, as we discussed. So now we're getting to equations with fractions. Okay, we will be doing fraction expressions soon. Okay, and that should help you with fraction equations. Okay, so yes, the first step, take a common factor, a number that can go into all of these numbers. Tell me quickly, someone. A value that can go into all of these, so I can take a highest common factor. Very good, 2. So when I take a common factor of 2, it's like I divide each term by 2. So I have x squared. I divide 6 by 2. 2 divided by 2 divided by 2. I get 3x minus 18. Okay. So firstly, before I even factorize, right, I notice that it is in trinomial form. Okay, because I have an x squared, I have an x, and I have a constant. Okay. So now I have my common factor. Now I have a trinomial. I try to factorize using trinomial factorization. So I keep my common factor in this case, and I open up my 2 brackets. Okay, I utilize my factors of x to give me first and last terms. Factors of x squared are x and x. Okay, I can put my signs because remember the first two terms are not different, so it doesn't matter where I put my signs. The second sign is a negative. So when the second sign is a negative, one gets a plus, one gets a minus. Okay, remember our rules from last week. Then I'm going to utilize the last term to get what? To get the last two terms. Sorry, the last terms in each bracket, basically. So those guys, okay, I'm going to use the factors of 18. Okay, remember in some cases, if you're going to have like a 2 there, it would affect it as well. So when our coefficient of x squared is just 1, we need to consider the variables of 18. Sorry, not the variables, the factors of 18. We need to consider two variables where we can potentially get a 3 or negative 3, where we can potentially get a 3 by adding or subtracting them. So if I think of the variables of 18, I think 1 and 18, I think 2 and 9, and 3 and 6, okay, whatever. 1, 2, 3, 6, 9, 18. Okay, so if I add and subtract them in my head, remember I need to use factor pairs. That's very important. So if I use 1, I have to use 18. If I use 2, I have to use 9. And if I use 3, I have to use 6. All right, so 9 minus 2, 7, 9 plus 2, 11, 18 definitely doesn't work. Clearly, we have to use 6 and 3. So I'm going to put 6, 3. In that case, it's not going to work because I'm going to get plus 6x minus 3x, which gives me positive 3x. I need negative 3x. Remember, when you run into that issue, it just means you need to swap your factors. Okay, always just do it in your head. Do outer inner in your head. So I know that here I'm going to get the negative. Okay, negative 6 plus 3. That's going to give me negative 3. Right? If I put the 6 here, I'm going to get plus 6 minus 3, which is not negative 3. So I put minus 6 plus 3, then I get minus 3, basically. Okay, so then that's we're just doing the expression. If I equate it to 0, I then need to solve for x. So each factor I will equate to 0. So 2 is equal to 0. Obviously, that doesn't make sense. X plus 3 is equal to 0, or x minus 3. I'm equating each factor to 0, right? Take 3 over to the other side, I get negative 3, or x is equal to negative 6. This is if it was an equation, and if they equated it to 0. Okay, you take each factor and you equate it to 0. Let's have a look at this example, right? So firstly, common factor. I definitely cannot take a common factor. Yes, with 6 and 12 I can, but 17 is the odd guy out. Why? Because 17 is a prime number, actually, so it only has two factors, one in itself, right? So there's no other number that can go into these that I can take a common factor for. So firstly, I'm going to solve it with a trinomial. Okay. So when I solve it with a trinomial, yes, I'm going to follow my same steps, utilize brackets. Okay, now I need to consider the factors of 6a squared. So the factors of 6a, we're just finishing up trinomials. This is our last example of trinomials. 6a squared. So firstly, a squared is going to be a and a. Each term is going to have an a. I can use 3a and 2a, or I can use 6a and a. Okay, so this is going to be trial and error, right? The more you practice, the better you're going to become, the faster you are going to become at determining which factors to use. So I'm going to try 3a and 2a. Signs, this is great because the second sign is a positive. When the second sign is a positive, both take the first sign in the trinomial, so both are actually negative. That's nice, right? Thereafter, I need to consider the factors of 12b squared. Again, it's going to be b and b. So there's many. It's going to be 1b or 12b, 2b or 2b and 6b, 3b and 4b. I think that's all. That's a 3. Okay, so now I need to consider outer inner. All right, I'm going to multiply the outer inner in order to get negative 17. I need to get negative 17ab. Don't worry about the variables because you'll see how they'll work out either way. So your main thing is I need to get negative 17. Again, like I said, the more you practice this, the better you are going to become at it. Okay, so if I consider both are negatives, right? let's just try and work with this, right? Again, these might be wrong. I might need to use 6a and a. Okay, but we are going to use trial and error now, right? So let's try 3b and 4b. If I put 3 times 3, I'm going to get -9. 4 is -8. Now, why does the first one work? -8 minus 9 is equal to -17. Okay, so unfortunately, the first one worked. I say unfortunately because I need to do a wrong one to show you how it's wrong. So let's try 2 and 6. Okay, so I'm going to put 6 there. Obviously, it needs to be B, but I'm just doing trial and error. Triangles, it's going to be after exponents, which is after this. Okay, I'm going to try 6 and 2. So when I do outer inner, I get -18 and -4. So clearly that's -22. That's too far, right? So now I'm going to try, let's just say 1 and 12. Okay, so I get -3 and -24. Again, too far, right? Then when you finally try 3b and 4b, it will work. So this is going to be, I need to get 9, so -3b. And -4b. Why are they negative? Because the second sign is a positive, suppose take the first. So here when I do outer in, I get -9 ab. If you see that, 3a, 3b gives us ab minus 8 ab. If I do inner, and that gives me -17 ab, which is the middle term, which is great. Okay, so those are my factors. Alternatively, this is a bit of a more hit or miss method. 6a squared minus 7ab plus 12b squared. I don't really recommend this method. It's very random, okay, and it's difficult to know when to do this and when not to do this, right? So trinomial is your best bet, but I'll show it nevertheless. It's grouping. So what we're going to do is, remember, grouping is 4 more terms. So I'm going to separate 17 into 9ab and 8ab. I'll tell you the reason I do these numbers specifically. I choose these numbers specifically because firstly, when I separate it like this, the first 2 terms, I can take a common factor, firstly of a, definitely. However, secondly, I can also take a common factor of between 6 and 9. So that's why I chose 9 and 8 specifically, because I'll be able to take a common factor between 6 and 9 and 8 and 2 as well. Right? If you don't, you'll be able to factorize it later on. If you choose different numbers that create 17, so maybe you chose -10 and -7, possibly you'll be able to factorize it later on. So now in this case, I can group. Okay, so I'm taking common factors between the first 2 terms and the last 2 terms. So between the first 2 terms, I do my numbers. Highest common factor between 6 and 9 is 3. Highest common factor between a squared and ab is just going to be 8. I'm left with 2a minus 3b. So I'm taking a common factor of a negative number now, right? Between my numbers, the common factor is 4, I believe. And between a, b, and b squared, the highest common factor is b. I'm left with 2a minus, okay, remember, because I'm taking a common factor of -4b. It's like you divide it by its common factor. So when you divide by -4b, you're going to get -3b. Okay, then I can identify, I have this and I have that, which are common. I can take that as a common factor, and I have 2a minus 3b as a common factor, and I have 3a minus 4b. Okay, another method to factorizing that. All right, then this example you guys can do on your own. So please solve that. Okay, as well as these, which you can go through. Perfect square trinomials, which we did one example as well. Oh, actually, okay, perfect square trinomial. Okay, you can just factorize this regularly, just like how we factorized the previous one. Okay, and don't worry about that. Okay, let's talk about sum and difference of 2 cubes. Okay, we are in grade 10. Then you can also use your calculator to solve it. Are you talking about a silver calculator? Okay, you can do one more example. Okay, just for the sake of time, okay, what I'd like you to do instead is to watch the previous example that I did last week as well. Okay, that way you'd have an extra example. Okay. Okay, let's have a look at this. All right. Factorization, sum or difference of two cubes. Okay, so in this case, we have two cubes, sum or difference. It's self-explanatory again, right? So sum plus difference minus two cubes, we have two different values, which are perfect cubes. Okay, or do you mean like another example of this? That specific example. Okay, we'll do it at the end. Okay, sum or difference, if you were talking about that specific example, sum or difference of two cubes. Okay, so plus minus of two different cubes. So here I have a plus, first criteria check. Doesn't have to be a difference, just either one. Two cubes. Okay, 8 is a cubed, 8 cubed is a cubed, of course. So that's a perfect cube. 27 is a perfect cube. So this is sum or difference of two cubes. So let's go through the steps. It says first bracket is a binomial. Cube root the two terms sign between that of sum. Okay, so basically it's saying that in order to factorize the sum and difference of two cubes, our first bracket is going to be a binomial, meaning two terms with the same sign as this. So this guy. Okay, whatever this is, if it's a sum, this is going to be a plus as well. Okay, so just note that. Now, as you can see, cube root the two terms. So the cube rooting each term. Obviously, you don't have to show each step. You're going to do it in one go. So when I cube root 8a cubed, I cube root the number first. Cube root of 8 is 2. And when I cube root a cubed, it's just a. Then I have the cube root of 27, which is simply 3. So I'm left with 2a plus 3. So that's what they're telling us to do. It's a binomial. How do you form that binomial? You cube root each term and you keep the sign the same. 2a plus 3. All right, first bracket done. Second bracket is a trinomial. So with the trinomial, you're going to form 3 terms. So for the first term, you're going to square the first term. Okay, so remember, this is first term in trinomial. When they say square the first term, they're talking about first term of binomial that we just created. Then the second thing is the first term times the second term, again, of binomial, with opposite signs to the first term. Okay, so okay, so basically that. Okay, and then add the second terms squared, add the second term squared. Okay, I'll go through it, explain with an example, it will make more sense. So how do we form this trinomial? Okay, let's take it step by step. Okay, so first step done. What is first step? Create binomial. How do we create binomial? Cube root the two terms between that, cube root the two terms, and you keep the sign that's between that of sum. So basically, you cube root each term, term 1, term 2, you cube root, and you keep the sign the same. Then we're going to form a trinomial. Now, in the trinomial, how do you form the first term of the trinomial? By squaring the first term of the binomial. So I'm going to square this guy. 2a squared is, 2a squared, yes, is 4a squared. How do I form the second term? Multiply the first and the second term. Multiply the first and the second term. So 2a plus 3 with an opposite sign. So the sign is positive, so negative. Negative what? 2a times 3? 6a. Then how do we form the last term? Firstly, the sign is always positive. It's always positive for the last term. Okay. And How do we form it? By squaring the last term. How do we form it? By squaring the last term. Okay, perfect. Yeah, that's what we'll do. So 9. Okay, so easy way to remember it. This is the sum of, okay, that could work as well. The easy way to remember it, first times first, opposite sign, first times last times last. Okay, a cubed plus b cubed. This is the sum of two perfect cubes. So we basically are saying, a plus b. How do you get a? How do you get from a cubed to a? You square root it, of course. So it's basically the square root of the first term. Sorry, the cube root, and the cube root of the second term. Okay. Then how do we form the second bracket? We take a, we square it. Opposite sign. Okay. How do we form the second one? Actually, a times b. Always positive last sign. And how do we form it? B squared. So this is basically the method, like if you consider it in terms of variables. Okay, a cubed plus b cubed is equal to a plus b, a binomial, and then a trinomial. How do you form these? You have to look at it relative to the variable. So in this case, we have a cubed. So you need to understand that why am I writing a there, and how would you use it with numbers? Basically, to get from a cubed to a, you cube rooted it. So whatever number you have here, you cube root. And then same with b. So these are cube root first term, cube root second term, same sign. Then we have, take that first term, which is a, squared. So now we're working with the binomial. First term of binomial squared, okay, opposite sign. Okay, I'm explaining that now, how to get the second bracket. So how do you get a squared? How do you get a squared? Okay, it's basically you're squaring whatever's the first term of the binomial. Okay, then opposite sign to what you just used. Then how do you get the second term? You take the first term multiplied by the second term. So that's why we have a times b. Then the third sign, this is always positive. Okay, and then we take the last term multiplied by each other, or you square the last term. Okay, so I'm just going to write it as the person wrote it in chat for the benefit of those who could utilize that. How do you get the middle term? I hope I answered for those who asked, how do you get the second bracket and how do you get the middle term? I hope that makes sense. So basically, in this case, you are going to take cube root. So we're going to maybe, okay, let's do this. Let's do a cubed plus b cubed, right? So a plus b, I think we all understand that, right? Keep the signs the same. Cube root, these guys, okay? Now, how do you get the first term? How do you get this trinomial? First term times the first term. Opposite sign. Okay. How do you get the middle term? First term times the last term. Okay. How do you get the second sign? It's always positive. Okay. How do you get the last term? Last term times the last term. Okay. Remember, we are talking about F is first term of binomial. L is last term of the binomial. Okay, so I hope that clarifies things. Let's look at a few examples. So I have the difference in this case of two cubes because I have two perfect cubes and I have a negative. So first bracket, okay, so I'm going to have, remember, a cubed minus b cubed is going to be equal to, firstly, a minus b. Secondly, a squared plus opposite sign, a times b, always positive, b squared. Okay, formula. So now I can utilize this with this example. So I can say what? I can say a minus b, which is the cube root of a 8h cubed. So 2h minus cube root of 125 is actually 5. Cube root of g cubed is, of course, g. So 2h minus 5g. Let's hope we get there, right? The quicker we can get done with this, the quicker we can do it to get there. A squared plus ab plus b squared. Okay, so let me square a. I get 4h squared. What am I squaring? Let's do it step by step. I'm squaring 2h. Right? Same sign, negative. Sorry, opposite sign, positive. Minus, plus. How am I getting this middle term? I am getting the middle term by saying a times b. So 2h times 5g. Opposite sign? No, sorry, always positive. Plus. How am I getting the last term? I am squaring the last term. And I simplify. 2h minus 5g, 4h squared plus 10hg plus 25g squared. Okay, so you guys can do the same for this last one. Just remember this. Get a and b, and then a squared, ab, b squared. Taking all these values and you squaring them or multiplying them by each other. Okay, let's talk about simplification of a fraction with multiplication and division. Okay, so steps in order to simplify fractions which have multiplication and division. Factorize the numerators and denominators, cancel like factors. Remember, okay, let's just go through some examples, right? So these are factorizations to do with fractions. I need to factorize. So on top, what can I do? Somebody tell me, what step can I take to factorize? What type of factorizing can I do? What type of factorizing can I do, eh? By the way, the person who asked, can you use your calculator? Do you have a silver calculator? Or do you have the regular gray calculator? Trinomial, trinomial. Okay, very good, trinomial, right? So I need to take out my factors. And I have factors of x squared that are going to give me my first terms, x and x. My second term is, my second sign is a negative. So one's going to be plus, one's going to be minus. I look at the factors of 6, that's going to give me negative 1. I'm going to take 3 and I'm actually going to put 3 there and 2 there. Why 3 there? Because negative 3 plus 2, that is equal to negative 1. So these are correct. So I'm going to now factorize. Okay. At the bottom, what can I do? You have a white one. Okay. I'm not sure exactly which white one you have, but if it's similar to the silver calculator, yes, you can factorize on your calculator. You're not really supposed to. However, you can. If you're going to factorize on your calculator, have you guys learned something called the quadratic equation? I don't think you guys have learned the quadratic equation. So if you're going to factorize on your calculator, you're going to have to, in order for you to, have you guys done quadratic equation? Okay, if you have, and if you're gonna use your calculator, you're going to have to show it in your calculator, because in your steps, you can't just put the trinomial, then say, I don't know, used my calculator to get answer. Okay, so you're going to have to show some sort of working out, because technically you're not supposed to be using a calculator. Okay, I would recommend that you do learn how to quadratically factorize, because at times it can be quicker, especially for easy examples like this. And in cases when it comes to like physics and you need to do it, and you need to do it really quickly, But yeah, if you are going to use a calculator, you put down the quadratic formula so that they can see that, okay, at least they use quadratic formula and then use the calculator. Okay, yes, at the bottom, correct, we do dots. So difference of two squares, remember, a squared minus b squared is equal to a minus b, a plus b. Right, so I'm going to have x minus 9, x plus 9. What am I going to do from there? Okay, I think they just wanted to factorize. They wanted us to factorize, so that's completely factorized, I believe. There's nothing to cancel. Okay, so we just canceled. Okay, let's draw a line there, no problem. Okay, now let's have a look here. Okay, top left, tell me, what can I do top left? How can I factorize this guy? Okay, wait. Let's just do this instead. Sorry. Yeah, correct. You are correct. You are correct. Indeed, I knew there was a mistake. Thank you for that. So the mistake here is I forgot to square root. Okay. So it's going to be x minus 3, x plus 3, right? And now, okay, remember this statement. Okay, guys, that person hasn't done. Where is the statement? Yes. Remember, the terms in a bracket can be considered a variable. Terms in a bracket, okay, can basically be considered almost like one term if you'd like, okay? So remember, when it comes to canceling, like canceling across numerator and denominator, oftentimes we cannot cancel with pluses and minuses. However, if we're canceling the entire thing, right? Remember, this is x plus 2 times x minus 3, x minus 3 times x plus 3. Okay, so in this case, I can therefore cancel this with that. And I am left with x plus 2 over x plus 3. Okay, no problem. Okay, so just remember that you can cancel these factors. So we're looking at this example. Yes, tell me, top left now. What can I do in the top left? What is KFC? Okay, so it's a type of trinomial. Okay, so let's just quickly add this to trinomials, right? What is the format of a trinomial? Okay, we have an x squared with a coefficient, okay, plus or minus an x plus or minus a constant number, 2. This is it. We could have a y squared plus a y plus or minus a constant number, okay. Alternatively, okay, we could also have x squared, okay, be careful, pay attention here, plus x times y plus y squared. Okay, so x squared plus x times y plus y squared. So it's not the same variable that we're utilizing. It's not a squared variable, normal variable, constant. No, this case, it's 2 squared variables. And that's why in the middle term, we actually end up with both variables there. Okay, simple explanation. Okay, so look out for these as well. Okay, so in this case, I can actually factorize it trinomially. Factors of a squared is simply a and a. This is a minus, so one's going to be plus, one's going to be minus. All right. Factors of 2b squared are basically 1. Okay. It's 2b and 1b. 2b times 1b gives me 2b squared. Okay. But remember, I need to get negative ab. So again, just focus on the coefficient of ab. You need to get negative 1. So you need to use 2 and 1 to get negative 1 somehow. All right. Negative 1. So in that case, I would put the negative by the 2. So I would put the 2 by the negative. So this is negative 2b, and this is positive 1b. To be or not to be. Okay, so that's factorized. Same thing at the bottom. Okay. Okay, I want you guys, I'm going to give you like 2 minutes to try and factorize the bottom, and please give me your factors. You can type in your factors. Anybody? Okay, I'll give like a few more seconds. Okay, so the first person that said a minus b, the first reason that cannot be true is because remember, when the second sign is a positive, both take the first sign. When the second sign is positive, both take the first sign. When the second sign is positive, both take the first sign. So they both have to be plus, firstly, I know that. Okay, now I need to consider the factors of a squared, which have to be a and a. Then I need to consider the factors of b squared, which have to be b and b. So there's no other choice in this specific case. There's no other choice besides a plus b, a plus b. Like we didn't have to use 2 and 1, for example, like in the previous one. Okay, so a plus b, very good. Okay, divide. So remember, okay, we are in grade 10 at this point. So a over b divide. Whenever we divide fractions, we don't have a method specifically to divide fractions. However, the method to dividing fractions is to flip and then actually multiply. So a over b, you keep your first term the same, multiplied by flip the second term. Please remember that. Right? So in this case, I'm going to do that one time. I'm going to change it to multiplication. I'm going to take a plus b to the top. And then I want to factorize this at the bottom. I'm just flipping it. Okay, I want you guys to factorize this example as well. Okay, could you remind me again, what is KFC, like factor? What does it stands for? Or what is it? I'm throwing a blank here. Okay, so just one more time, please try and factorize this. Okay, it needs to go in the denominator because we flipped it by multiplying and then we flipped the fraction. Okay, in the YouTube chat for earlier, yes, a plus b is correct. Leave me, change me, flip me. I'm not sure what's that. If you would like to expand. Okay, again. Okay, a minus 2b, okay, good. Okay, a minus 2b, great. Okay, so yes, factors. Second sign is a positive, so both are indeed negative. Factors of a squared are a and a definitely. So for this one, I have 4b and 1b basically, or 2b and 2b. So if I try 4, so now it's easy when they both minus, you know that you're going to subtract both of them. They're going to be negative 4b and negative 1. So it's going to become negative 5. That's not what I want. So I definitely have to use negative 2b, negative 2b. When I do outer inner, actually, I get negative 2b minus negative 2b, which is negative 4b. Okay, so now that's the factorization done for dividing fractions. Okay, cool. Okay, yeah, that you could learn it whichever way you learn it that time. Leave the first one, change the sign, and flip the last fraction. Brilliant, right? That works. Could also, if you learn tip in times or flip in times, whichever one you've learned. Now we're going to revise simplifying fractions. Okay, so for example, not example, but in this specific case, anything in the numerator and the denominator we can simplify. Whether it's the numerator of the first term and the denominator of the last term, we can simplify. Okay, so let's do a basic example. Let's just say we have 10 over 25 times 30 over 15. Okay, so literally I can divide, I can keep change flip. Okay, thank you for that. Yes, you can cancel out things, correct, right? So this is just a basic example. I can simplify 25 and 30 by dividing them both by the same number. I know that a number that can go into both is 5. So I can make that 5 by dividing it by 5 and that by dividing it by 5. And I get 6. Then I can even, because that was numerator, denominator, then I can even do one more with 10 and 5. I can make this divide 5 by 5, I get 1. Divide 10 by 5, I get 2. I can, that's it. Okay, so I'm left with 2 times 6 over 1 times 15, which is equal to 12 over 15. Okay, simple example. So similarly in this case, right, I can cancel out entire brackets. Must you put the bracket on the one that does not have brackets? Yes, sorry, I thought I did. You don't have to, like don't get me wrong, you don't have to. It just makes more sense for when you're canceling out. So let's start canceling out, right? So firstly, anything in numerator and denominator, so a plus b, a plus b. A plus b on the top right, a plus b on the bottom right, bottom left, sorry. A minus 2b, a minus 2b. So on top, I have nothing left, but remember, I'm left with 1 because when I cancel this and I cancel that, I divide them both by themselves and I get 1. Okay, so I'm left with 1 over whatever's left in the denominator, a minus 2b. Okay, thank you for that. In the YouTube chat, they did tell me. Keep flip change. Keep flip change. Now I remember. After they told me. Okay, so yes, you guys are free to enjoy all the bounties of this example. Looks immaculate. Okay, let's talk about simplifications with addition and subtractions, and then some restrictions on fractions. Okay, simplification of fractions with addition and substitution. Is this method tip in times? Yes. Do you have to put the 1? Yes, you have to put the 1. If you do not put the 1, what are you going to have? Are you going to have 0? Okay, you have to put the 1 because even though you're left with seemingly nothing, you need to remember, right? Look at this example, right? When we said 10 over 25 times 30 over 15. Here, okay, for example, let's do it here on the right-hand side. If I chose to do 30 and 15, I divide 15 by 15, I'm left with 1. So I don't technically have to put it, but I should put it. 30 divided by 15, I get 2. I'm left with 2 over 1. So similarly here, it's like I'm canceling out a plus b because I'm dividing them both by themselves. I'm saying that divided by a plus b, I cancel, it's 1. So for all of them, you should put 1. Okay, you don't technically have to if you understand it or if it doesn't confuse you. Whenever you're left with nothing, however, you are left with 1 because you are dividing them each by themselves to get rid of them, and you end up with 1. Okay, so let's look at this. Factorize the denominators and numerators. Cancel like factors in each term, if any. Find the LCD. Put each term over LCD by creating equivalent fractions. Put each term over LCD by carry out the products. Okay. Okay, a bunch of baby steps. Let's just go through the practical example. Okay, so factorization of fractions, no, just addition or subtraction of fractions with factorization, so complicated examples, okay, at a grade 10 level, basically. Okay, so for the person who asked for fractions with equation of fractions, this is similar. Okay, the only difference is when you have an equal to sign, if you're taking anything over to the other side, you're going to change it from a negative to a positive and vice versa. If one is 1 on top, then you must put the 1. If it's at the bottom, you don't have to. Yes, that works as well. That makes sense. That's logical for someone to remember. Okay, if it's 1 on top, you don't have to put it. If it's 1 at the bottom, sorry, if it's 1 on top, you should put it. If it's 1 at the bottom, you don't have to put it. Okay. So let's look at this example. Okay. So firstly, tops, nothing to factorize, simplest form. Bottom, however, yes, very good, trinomial. So let's do the trinomial factorization of each one. So give me brackets quickly. Okay, and then while you are giving me brackets, I just want someone to answer me. Was it one of you guys in this class that asked for the timetable last week? Just yes or no, because I can't remember. Oh, either way, okay, I'll hopefully send it out by today. I think it might have been grade 11. X minus 3, x plus 2. Okay, brilliant. So I have a negative. Okay, so one's going to be plus, one's going to be minus. It doesn't matter where I put it in this specific case because my factors of the first term are the same, x minus 1, x plus 1. What I mean when I say that, by the way, is I could have put the minus first and the plus second. It didn't make a difference, okay? However, for example, if it's like 2x and x, now they're different. So now I need to consider where I put the negative or positive because it's going to make a big difference, okay, because they're different. Okay, then factors of the last term are 6 and 1 or 3 and 2. 3 and 2 give me 1. I need to get negative, so I put the bigger number by the negative. So minus 3 plus 2 essentially gives me minus 1. Minus 3 over x minus 3, not simplifiable. Minus 3 over, sorry, not factorizable, over x plus 2. Okay, so whenever we do fraction, adding or subtracting fractions, the method to solving it, which you guys should know by now, is to do lowest common denominator, highest common denominator, LCD, lowest common denominator. We need to find the factors of the denominator, common factors of a denominator that are the lowest ones. Okay, so for example, if I have 3 over 10 plus 4 over 15 minus 2 over 20. If I want to find the LCD here, okay, very good. That is correct. If I want to find the LCD here, I need to find a number that goes into each of these denominators an exact amount of time, and it needs to be the lowest number possible. Thank you. It needs to be the lowest number possible. So in this specific case, wait, lowest common denominator. Sorry, it needs to be not a factor. Lowest common, it needs to be a multiple of each number. So these are terrible. Okay. It needs to be a number that is a, can't 20, can be 5, because 20 can't be 5, isn't correct. Okay, yeah, sorry. I asked the wrong question. For those of you that said 5, we are not looking for the highest common factor. We are looking for the lowest common multiple, which is essentially the lowest common denominator. It needs to be a multiple of all the denominators that is the lowest possible. Okay, so firstly, if I say 10 times 15 times 5, I am definitely going to get a number that is a factor of all of these, because I'm multiplying all of them together. So if I work backwards, 10 would be a factor of that number, 15 would be a factor of that number, that would be a factor of that number, right? I believe that number is 750. So I could use 750, but that's not the lowest possible multiple. Okay, the lowest possible multiple, again, you could use LCD that you learned in grade 8 if you're really stuck. Alternatively, you could just use this one is easy. So we know it's going to be over 30. So you can put each individual on over 30, or alternatively, you can just put them all over 30 at once, just like I did here. So I need to consider, okay, you know what, let's just do it separate. So we don't rush 30, 30, 30, right? So remember okay, we didn't learn this, but when we have a fraction, we need to keep the ratio the same. So 3 over 10 must be equal to whatever I have over 30. So how do I go from 10 to 30 in the denominator? Whatever change I made to the denominator, I need to make to the numerator. The change I made in the denominator was I multiplied by 3. So I make the same change in the denominator, in the numerator. Okay, not 2. 30 is the correct answer. Then what change did I make to this numerator to get to 30? This denominator, sorry, I multiplied it by 2. So whatever I do in the denominator, I do in the numerator, and I get 8. What change did I make to that denominator to get our new one? I multiplied it by 6. So whatever I do in the denominator, I do in the numerator, and I get 12. Now I can simply add them because they are all one denominator. I can add them, right? So then I get 9 plus 8 is 17 minus 12 is 5, I believe. Simplify to 106. I think that's right. So long, just tell me, I'll fix it now. Okay, quickly, let's try and end on this. Okay, so now this is a bit complicated because we do not have numbers. We do not have numbers. We have factors and then numbers with variables. Okay, so in that specific case, right, we treat each factor as a variable. So that's a variable. That's a variable. These are the same variables. These are the same variables. Okay, maybe these colors are a bit too close. Okay, so x minus 3, same type of variable, x plus 2. So we could treat this like we have 3x squared over xy minus 3 over x minus 3x over y. It's almost like the same thing. Okay, that's how we should treat it anyway. Okay, like that's one variable, that's one variable. So I just like replace it with one, call that x, call that y, call that x, call that y. Okay, and then in this specific scenario, what we would do, okay, is we would say our lowest common variable is actually lowest common denominator when it comes to variables, right? One second, it's my load shedding. Is at 12. Okay. Lowest common denominator when it comes to variables. Okay, let's just say with what you actually want to do is you want to choose each variable with its highest power. When we say highest power, we're talking about highest exponential power. Okay, so keep that in mind. So in this case, x is one of my variables. Okay, you don't duplicate variables. Y is one of my variables. X and Y are the two variables. The highest powers are 1 each. So my lowest common denominator here is just going to be x times y. I've chosen the highest power of each variable. Okay, so just keep that in mind. Okay, let's continue this question, however. So now, if I treat this as a variable, and this is a variable, the highest power of each variable is 1, okay? Because technically I could have x plus 2 squared. That means I have 2x plus 2s, x plus 2 and x plus 2. Okay, in that case, the highest power would be squared, and I have to choose that answer. Okay, so it's not squared. Okay, so its highest power is 1, highest power 1, highest power 1, highest power 1. Okay, so in that specific case, right, I need to choose each variable. Okay, so I need to have x plus 2 and I need to have x minus 3. Both of them, those are the two different variables I have across all my denominators. So I have to choose x plus 2 and I have to choose x minus 3, and I will choose it with its with its highest power. Its highest power in this case is x, just itself, x plus 2. And then the other variable, x minus 3, yes. Okay, so I hope that makes sense. Yes, alternate, you could use any other types of understandings that you have for this, right? You can understand that this is a factor of that because I already have these two in this term. Okay, so what did I do to get from this term to our new term here? I actually just multiplied by 1. It's the same thing, right? So then I multiply this by 1. This remains 3x squared. Sorry, we're going to end shortly. Then I keep the sign the same, minus. Okay, let's just box this guy. New. Okay, then I have minus. How did I? So remember, my new common variable has to be the same across all, right? So even for the second term, the new denominator, sorry, needs to be x plus 2 and x minus 3. Okay, so how did I get from x minus 3 to x minus 2 and x minus 3? I had to have multiplied by the other variable or the other factor, which is x plus 2. So in this case, I multiplied by x by 2. So the top I will multiply by x plus 2 as well. So I will be left with 3 into x plus 2. And then let's look at our last one. How did I go from x plus 2 to a lowest common denominator of x plus 2, x minus 3? Okay, I actually multiplied it by x minus 3. It's basically like what's missing from that denominator compared to the lowest common denominator. Okay, so 3x times x plus x. Okay, I messed up something here. It's minus and plus. Nope, it was right the way it was. So it's missing x minus 3. Okay, so we'll continue next week. We are basically done. We just need to do restrictions, and then we're going to move on to exponents. Okay, and hopefully exponents. The actual theory is not that long. Yeah, we should get to electrostatics tomorrow, by the way, for physics. The actual theory of exponents is not that long. We'll go through each rule, and then it's just about practice, okay? So we can get as much done as possible, okay? Then you guys can just practice as well, okay? So we should be able to finish exponents in our next lesson. I will send out I'm not going to send out the timetable because it's difficult to predict what we're going to finish. However, I'll send out just a list of the next few topics that we're going to do. But yeah, okay, that is all we have time for. Thank you guys so much for joining. I hope you guys have a good week of school. Jazakallah khair. Thank you guys so much. I will see you guys next week. Assalamu alaikum and goodbye.